Okay, in this video we're going to do problem 12 on the final exam review. It says write and evaluate notations, including nth terms. See homework from 12.1 and focus problem 10. So these are a few problems I've taken from section 12.1 that emphasizes writing and evaluating notations. So these two forms here are in explicit form. So that means we can just put in values here. A sequence is basically a rule where n is the domain. The domain happens to be integers from 1 to infinity. So your domain here is going to be n equals 1, 2, 3, 4, and so on going up. So your sequence B is going to be when we plug in the numbers. So first B here, I'm going to do 20. You can do 19 and check your answer in the book because that's an odd number, but I will do 20 here. So B sub 1, the first number in this sequence would be 2 plus 1 divided by 2, which is 3 over 2. Second number in the sequence is 2 times 2, which is 4, plus 1 divided by 2 times 2, which is 4. So that's going to be 5 over 4. The third number in the sequence is 3 times 2, which is 6, plus 1 over 6, which is 7 over 6. And B4 is the fourth term in the sequence is equal to 4 times 2, which is 8, plus 1 over 8, which is 9/8. And B5, which is the fifth term in the sequence, is 10 plus 1 over 10, which is 11 over 10. So our sequence would be 3 over 2, comma, 5 over 4, comma, 7 over 6, comma, 9 over 8, comma, 11 over 10, comma, and it continues on from there. And this is the rule for the nth term, so that would be what we would put on the last term, 2n. So 2n plus 1 over n would be our last term, because that's the rule for that. We'd be keep plugging those numbers in there. So this would be our sequence to the nth term, and this would be the nth sequence. This is the first 5. All right, and that's when it's written in explicitly, and it has these quotation things around it, and that's how you tell it's explicit. Okay, now the other part of the assignment is what we call recursive. A recursive definition means it's based upon the first term and a rule for every term after that based upon the first term. So if we're looking at 38 here, it tells us the first term is 3. So we'd start off with 3. That would be our first term. Then it's saying that every term after that, a sub n, is going to be 4 minus this thing brings the previous term. Because this is n minus 1 term, and we're starting at n, so the nth term is the term we're on, n minus 1 is the previous term. So here's our previous term. This is going to be 4 minus this term. So the next term is 4 minus 3, which is 1. The next term is going to be 4 minus 1, which is that term, which is 3. So this just alternates, because the next term is 4 minus 3 again. So it's going to alternate back and forth between 3 and 1 forever. Okay, that's how that works. All right, like if we did 37, we're adding 3 each time. So we start at 2 and add 3 each time. So if we were doing 37 as a rule, we'd start off with 2, and then we'd add, this is a previous one, we'd add 3 to the previous one. So we add 3 to this and we get 5. We add 3 to that, we get 8. We add 3 to that, we get 11. We add 3 to that, we get 14. So this is the recursive definition. It's taking the number and adding 3 each time. This is taking the previous one, or taking the term number minus the previous term. So it's a little bit different that way. We would then look at what term we're on then. This is multiplying by 2, so it's twice as much. So to start off with 5, then it would go to 10, then it would go to 20 because it would be multiplied by 2 each time. Alright, so that's writing the terms. That's writing the things out. Now we also have to be able to evaluate the notation for the nth term. So if we wanted, these are some problems given where we're supposed to write the nth term out of the sequence. So here, like in 30, we can see that in this term, n is 1. So n equals 1, that term is 1 over 1 times 2. If n is 2, we got 1 over 2 times 3. Now, the 1 on the top is not changing, so the rule for this is going to be, say we use a sub n as a rule. We're going to start with 1 in the numerator because it doesn't change. Now, the two numbers on the bottom are based upon this number here, n. So this number here and this number here look to be the same every time. So on the third one, that's 3. On the fourth one, it's 4 right there. So that's just going to be n right here times this number is always looks like 1 more than the n number. It's 3, then it's 4, so it's n plus 1. So this is our formula for number 30. We have a 1 on the top. We have a 1 and a 2 and a 3 and a 4 on the bottom. And we have the next one up from there, 5, 6, 7, 8. Now, if we were going to do something like 35, those just matches the ends, but it alternates in sign. So in 35, we have to do something with the sign changing. So, and we have to do that on number 33 too. If the signs alternate, so we have to add something to the rule so that we can alternate the signs. So that's going to happen when we have -1 to some power. All right. So if we start off with the first power of that, that's going to give us a negative number. So -1 to the first power is negative. But if we want it to be positive, we're going to need to add 1 or subtract 1 from this. Usually I just add 1. So that means now when we put in 1 to this equation, it'll be -1 to the second power, which is +1. And we're going to multiply that by n, because n is the term number that we're at. So 1 is going to give us that. 2 is going to give you a 2 here times -1 to the third power, which is negative. So it's -2. So it's going to alternate back and forth. This causes alternation back and forth between the signs. This is the n because we have 1, 2, 3, 4, 5, 6 in the thing, so it just changes. N is 1, n is 2, n is 3, so on and so forth. It's an n just like this n is in this previous problem. So that is number 12, where you have to write the sequences or you have to evaluate them, whether they're explicit or recursive.